Hello, today we're going to do another problem by Cal Academy, array problem set number 4. The problem asks us, given an unsorted array of integers, meaning it could have negative numbers and positive numbers, find a subarray which adds to the given number or the sum. So what are our inputs? Our input is an array full of integers and a sum of some number. This is 33 for this case. So our output should be in the indexes of 2 to 4. Because if we add all of these guys together, this would output 33. Right here. That'd give us 33 if we added all that up together. So we have to figure out how exactly can we find the subarray that equals the given sum. So this should be done in an O(n) time complexity as well as an O(n) space complexity, because how we're going to solve this with the space is we're going to have a hash table or a hash where we're going to be storing the sum so far into the hash, and we want to look up on that hash to see if the difference between our sum so far and the target exists in the hash. If it does, then we know that if we were to take that number away from the sum so far, we would get the correct answer. So I know that's a lot of information. So what does that look like exactly? So what I mean by that is we are going to have a sum so far variable. So we can call that, I'll just say that it's going to be called current sum. Say that. We're going to set it to 0. And then we're going to have our hash like we said. We'll say let hash go to this object. Then we're going to loop through our array, and we're going to add each number to this current sum. So when we do that, right, we're going to add 1 to 4, then 5 to 20, then 25 to 3, 28 to 10, which is 38. So at some point, we're going to have all of these numbers added up, and it's going to be 38. What we want to do is take 38 and subtract the sum from that. And from that, we will get 5. 5, we know that if we take away 5 from 38, that'll give us 33. So these two numbers right here give us 5. That gives us 5. So what that means is if we take away those indices, and then we would have the correct target. So if we take away those indices, 0 and 1, and move the index up to the second position, then we know that that would equal 33 for us by taking those away. That's what I mean by if we take the difference of the current sum and the target, we check to see if that sum that we've added to our hash exists. If it does, then we just are going to take that that index, which would be the 1th, and add 1 to it, which would give us the second index. So let's see how that looks. So if I loop through here, say let I equals 0, I less than array.length, I plus plus, and I'm going to say if the sum equals target sum, return 0 to I, because if the entire time we didn't have to do any subtraction, and all we had to do was just keep on adding, then we know that it's from 0 to wherever we're at. We know that, oh, from 0 to here, like we've just been adding, so it must be equal to 0 to where I is. So we just say if well, first let's add. So we'll say current sum plus equals array at I, which is the current number we're on. And then we just ask if current sum is equal to our, excuse me, I forgot to add in target up here. It's equal to the target. Then we know to return from 0 to our current index, because we didn't have to do any subtraction to get the number. We've just been adding all the way up until this point, so it must be 0 to the current index we're at. Excuse me. All right, so now the next thing we ask, okay, is then if the difference of the sum and the target is equal to a sum that is in the hash, then we're going to return the difference. That difference is index plus 1, because we know if we take away that that sum, we need to increment our index. So then we say if the inside of the hash, the current sum minus the target that exists in there, then we're just going to say, okay, then return to me the value at that hash plus 1 to the current index, because we know that if we're at the current index without 5's index, we know that we're going to have the correct range from 2 to 4. So we've taken away 5, which was at index 1. Then we ask else, okay, else if that difference isn't in the hash, we're going to just add the current sum to the hash and set it equal to its index. Now, if we go through this entire thing and we don't return anything within the for loop, we're just going to return null, meaning that there is no subarray that equals it. So if we step through this again, okay, we have 1 and 4, 1 and 4 and 20. Let me take away this. Take away this. Okay. So we start at the first guy, which is 1. We add it to 0. Current sum becomes 1. We ask, is 1 equal to 33? No. So then we ask, all right, is 1 minus 33, which is what? Negative 32. Is that in the hash? No, it's not in the hash. So then we add it to the hash. So then the hash here has 1 is equal to 0. So then we move on to the next number, which is 4. We add that to 1. So now it's 5. Is 5 equal to 33? No. 5 minus 33, which is what, negative 28. Is that in the hash? No, we only have 1 in the hash right here. Okay, so then it's not in there. It's not in the hash, so then let's just add the current sum to the hash, which is 5, at its index. Then we move to 20. We add 20 to 5, so 25, is that equal to 33? No. 25 minus 33, that gives us negative 8. Is negative 8 in the hash? We just have 1 and 5. No, it's not. So then we add 25 and its index to the hash, which is 2. Okay, we go up and then we add 3 to 25. It's 28. 28 is not equal to 33. 28 minus 33 is negative 5. Negative 5 isn't in the hash, so then we add 28, its index. We go to 10. Now it's 38. 38 is not equal to 33. 38 minus 3 gives us 5. 5 is in the hash. And we know if we take away the 5 from 38, that'll give us 33. So let's take the value of 5, which is 1, and then add 1 to it, meaning its index position is 1. That's where 5 lives, is at 1. So let's take it away and move it up to index position 2. And then that would be what we return, which would be 2, 2, 4. That's where we're at right now. And then that's how you solve this question. And this would work also for negative numbers, because it would be just using the same logic. If we go through it and adding up negative numbers and subtracting, we get the same result. So that is how you solve this problem. Thanks so much.